Okay, cool. So yeah, basically, I think last week where we got to, let me just share my screen as well. Which screen can you see? A notebook?
No, we're seeing a terminal.
Ah, okay. Let me try again. Yeah, should be a notebook, right?
Yeah.
Okay, cool. Yeah, so I think last week we were working with the Ocean Pi, so like the Python library for using Ocean. And the idea, what we went through in the first week was going through the graphical user interface and just using the Ocean marketplace. But now we've started using this Python library, and that means that we can explore data sets and download data sets in Jupyter notebooks, basically. So we went through this last week. We set up our wallet, all this sort of stuff, and downloaded the sample data for the CryptoPunks. And yeah, and then displayed the sample data. And so this is the start of the workflow that a data scientist would go through if they wanted to work with a data set, for example. I think a lot of this can be hopefully like abstracted away. So we also talked about, what sort of library could we build to reduce a lot of this. So for example, could we store a collection of addresses for the data sets and then, just be able to basically write like download CryptoPunks in a single line of code? I think that would be really useful instead of having like all of this code to download a data set in a notebook, which is where data scientists tend to work. So yeah, what I can do, like that would be something that's interesting to explore in the long run. Yeah, the other thing that we did last week was, I think actually since we met, I set up this project board, so a Kanban board for issues and stuff like that. And I started adding all of these issues. So what I've been doing up until now is basically just preparing for these hacking sessions by myself. But what I'm planning to do from now on is to put up all the stuff that I'm working on for the hacking sessions, create issues for them. And then if people are interested, they can, help me out with these issues. And if people aren't interested, I'll just, work away on them and complete them. But it means that I'll be working out in the open. And so if people wanted to dive into some of the problems, they have the ability to. And of course, as we said before, we're using SourceCrowd to track contributions on the GitHub at the moment. So the more contributions people make on GitHub, the more cred they'll get. And we're hoping to use cred in future as like some contribution to the ownership of Algovera, for example. And so we're still kind of practicing with that, I suppose, and testing it out. So like a few people were chatting. The first issue I put up was explore simpler alternatives to StyleGAN. So we talked about using StyleGAN 2 originally, which is quite a big model and it's often used on high resolution images. So originally we hadn't decided that we were going to use CryptoPunks, so StyleGAN 2 made a bit more sense. But because we're limited for compute a bit, we decided to use a lower resolution image dataset, and we decided on CryptoPunks. And that the question was then, is StyleGAN 2 overkill for what we're trying to do? And there were like a few people were suggesting some alternatives, so like DCGANs, BGAN, which I haven't heard of before, and then Holly also linked a repo with some pre-trains of StyleGAN 2 models. So, rather than training StyleGAN 2 from scratch, because that would require a lot of compute, what we could try is transfer learning on StyleGAN 2. So I think all of these are really good options. And in fact, like we can do more than one as well. So like the quickest thing for me to do was just to like play around with DCGAN, but I think it would be really interesting to explore transfer learning for StyleGAN as well. And also there's like some people have trained some models on CryptoPunks before. So there's a few like blogs and stuff here as well. What else were we chatting about? So yeah, I guess like this one is kind of solved. So I think like DCGAN is one that I'm going to show you this week. And also I think we can use StyleGAN too and experiment with transfer learning on that. The other thing that I've been working on was getting the compute to data working. And this is basically, there's already a README for this in the OceanPy docs. So I basically just implemented this. The only difference being is that if you follow this tutorial, they set up, you probably won't have heard of these things before, but Ocean Protocol has a repo called Barge. And what Barge is, it includes a lot of different stuff. One of them is Ganache, and Ganache is basically software to run a local Ethereum blockchain on your laptop. And so rather than using, the mainnet of Ethereum or a testnet of Ethereum, you actually like just run a blockchain locally on your PC. So no one else can like write to it. And people use this a lot for experimenting with different things on the blockchain. But so we don't want to do this. We want to like play around with data sets on the real, on the testnet, the Rinkeby testnet. And so if you're following this tutorial, you don't need to do the Barge part. So what I did was I basically used this tutorial, but I changed it to use the, let me get it up here. So I changed it. Oh, this is a different PC. Yeah, I'll show you in a bit, but I changed it so that it uses the real Rinkeby testnet. And so we basically just replace, this is where we set up based on a config file, which I showed you last week, I think. And so rather than using Ganache, we just set up the config to use the Rinkeby testnet. And so that's another thing I was working on, which I can show you in a bit. Does anyone have any questions so far? Okay, cool. And then just
sorry, Richard. Sorry, I wanted to. So you will upload this, right, on the GitHub? Like I can pull it down because how I ran into problems with that Barge and all that. So I really want to understand how what we are doing here. Okay,
yeah,
cool.
There were quite a few issues actually, and even like the README for the README from the OceanPy walkthrough had changed a bit as well. So this is the thing with Ocean, just because it's an alpha version, so things are changing regularly. So like when you run it one day, it might not run the next. And so I've changed it so that it works with the current OceanPy version, and you can play around with that basically. So yeah, I'll push that right after we finish up here. So
thank you.
Yeah, no problem. And the other thing that we're going to do today is run a generative model on sample data locally. So a few things have changed, I guess. So what I was originally thinking was, so the issue with using compute to data with Ocean is that you only get like 60 seconds of compute before it times out. And of course, like 60 seconds isn't that much if you're like training an algorithm or something like that. And so what might be a better first step than training. So what we need to do is basically set up a new compute provider. So rather than using the compute provider that Ocean uses, we can set up a custom compute provider that works on Amazon Web Services, for example. Of course, that means we have to pay, but actually we're going to work with Robin and Data Union, who they have some credits for AWS. But like swapping out the compute provider is something that is more difficult than just using the existing Ocean compute provider with Ocean. And so before we train a model that takes longer than 60 seconds, I think it makes sense to publish an algorithm that runs in less than 60 seconds, just so we can learn the process using the Ocean compute provider. And then once we're happy with that, then we can switch out to our own custom compute provider and train for longer, I suppose. And so the idea was that we were going to, the original idea was that we could write a data processing algorithm so that because StyleGAN2, it processes the data sets that it trains on into a particular format. And so we were thinking that we would upload the raw data to Ocean, and then we could upload a data processing algorithm to Ocean. and we could run that data processing algorithm on the raw data, and then that would give us a processed data set, which we could also upload to Ocean. And that data processing should take less than 60 seconds as well, I was thinking originally. But now that we're like for DCGAN, for example, though, you actually don't need to process the raw data. It works. It just works on the CryptoPunks data set that's up there already. And so I was thinking, instead of writing a data processing algorithm, what we could do is just write some really simple algorithm that, for example, counts the number of images in the CryptoPunks data set or something like that. Something that takes less than 60 seconds. And then we can publish that algorithm on the marketplace and run it using this Ocean's compute to data infrastructure. And then after that, once we know how to do that, we can swap out the compute provider for our own one. And that means that we can actually train DCGAN or StyleGAN 2 or whatever we want to do. So what I'm going to do is I'm going to change this issue here. Just instead of saying publish algorithm for data processing, just write publish an algorithm for some simple thing that takes less than 60 seconds, I suppose. Does that make sense? Does everyone agree with that process, or does anyone have any questions?
Makes sense to me. So.
Okay, cool. Yeah. So what I can do as well is now that like these three are almost done, I can add some more issues on this board for during the week. And yeah, if people are interested in digging in and coding, I'd say like this is the best place to come and figure out. And then if you have some questions about an issue or something like that, just reach out. I'm usually pretty responsive on Discord. So yeah, let's just work as interactively as possible. And also like the generative art channel on Discord is quite active. So it'd be great to get some conversation going in there. Yeah, and yeah, I think it's a good way to work to use this issue board. But if anyone has any suggestions for improvements, like please let me know. Okay, cool. So as I keep saying, the workflow for data scientists is quite different when you're using this like private AI infrastructure and also the data marketplaces. And so as everyone knows, Jupyter notebooks are how data scientists usually like to work. So if you want to work with, if you find an interesting data set that you want to do something with, you'll probably go to a Jupyter notebook. And then you want to download some sample data in the notebook just to have a look at what it, the folder structure and just what it looks like in general. And so that's what we were doing with this notebook. What you might do next, after you've opened the data in the notebook, what you want to do is build a model and pass the data as input into that model. And so we can do that in the notebook as well. But the only thing is, now that we only have the sample data, we only have a few examples to pass into our model. So this is a little bit different to how data scientists might work. Although it is quite common for a data scientist to what's called overfit on a small sample of the data. And so the idea is neural networks, what's different from traditional software development is that if you wire up a neural network wrong, the program will still run and it won't tell you that you have a bug or that you've made a mistake. And so this is a good thing about machine learning and a bad thing all at the same time. It's a good thing because your code will generally run. It's a bad thing because you don't know that you've got a bug necessarily just because your program runs. And so what people do sometimes is, rather than train on the full data set, they'll train on a small sample of data or even just a single sample. And the question is, can our model learn a very simple mapping on a single sample? So like if you have one picture of a cat and you need to figure out if that's a cat or a dog, for example, if your algorithm can't learn how to map a single image to its category, how is it going to learn to generalize on like a larger data set of like thousands of images? And so, yeah, we try to basically what's called overfit on a single sample. And if we can't overfit on a single sample, it means that there's some issue with our model. Maybe we've wired something up wrong or something like that. And so this idea of working with sample data when we're working with compute to data and private infrastructure actually suits the workflow of a data scientist, because often we'll just work with a small sample to start anyway, even when we're not using this private AI tech. Did that make sense? Does anyone have any questions? Okay, cool. Yeah, so like I said, the first thing is to like have a look at the data in our notebook. So that's what we did last time. And the next step would be maybe to train a model on the sample data. And so I was just looking up DCGAN, just because DCGAN is easier than StyleGAN 2, as we said. And there's even a DCGAN example in the PyTorch docs. So for those of you who don't know PyTorch is like probably the most common, one of the most common frameworks for deep learning research. It's made by Facebook, and like the other big one is TensorFlow by Google. And so DCGAN is a generative adversarial network that works on images. So yeah, basically all I did was just copy and paste this code into a notebook and run it on CryptoPunks. So it's really simple. And so, yeah, we had downloaded the data from last time. I'm just going to restart this. Yeah, so we had downloaded the Punks data from last time. And if you remember, the Punks data has like clear backgrounds as well as like teal backgrounds. This is what that's very small. This is what the teal backgrounds look like, and this is what the clear backgrounds look like. And so, as I said before as well, when someone's uploading a data set, the sample data should have the same format as like the full data set. And so I'm not going to click on Punks because there's too many images, but when we click into Punks and Punk sample, it should have the same folder structure of clear background Punks and teal Punks. And the idea with having the same folder structure is that if we write a model that works on the sample data, we also want to have confidence that it's going to run on the full data set when we send the model off using compute to data. Okay, so we downloaded that last time. I was just playing around with the teal images. I don't know if there's, I don't know which is better, clear images or teal images. Maybe Holly, you would have, you've probably played around with this before. Maybe you'd have some insight on teal or clear backgrounds.
Yeah, I think it has to have a solid background, non-transparent background. So that's why I created the teal ones based on what they were saying. That's the teal color of the CryptoPunks. So yeah, and then I also the actual image comes as just one image, and so then if I had some code in there that used FFmpeg to break it up into each individual image. I don't know if that's something you want to. I could add to the data set at some point in terms of how we processed it. So, but
okay,
yeah,
cool.
stick with the teal.
Very cool. Yeah, yeah. That's the reason I chose the teal to train, because I was wondering whether the clear backgrounds would work. Like maybe, I think I tried to load one in and it either loads it as white or black usually. So yeah, I just went for teal for that exact reason. Cool. So this is where we got to last time, where we just loaded the images, I suppose. And then all of this code I'm about to run is basically just from this DCGAN tutorial. And so I'm actually not sure that this model trains if you do it on a small sample. What I might do first is cheat a little bit and just show you on the full Punks dataset. I'll run this for like 25 epochs. So again, all of this is just loading in all of the Torch libraries and setting the parameters for training and creating your dataset out of the folder. So PyTorch works with dataset classes. So every new data set that you want to train on in PyTorch, you create a data set class for it. And that's basically what we're doing here. And we're creating it from our image folder. So you can see a few of our different teal punks here. And just initialize the weights of the network. Then some of the different modules that are in DCGAN. So for example, in a GAN, we always have a generator and a discriminator. So we're just defining what they look like. And the generator and discriminator are just like a collection of different types of layers. So these are like transpose convolutions, for example. I'm not going to go into too much detail. So just defining what our discriminator looks like, initializing it. So defining what our loss function is, in this case, binary cross entropy, and also what our optimizer is. So there's different ways of updating the weights of the network. And then this is our training loop. This is where the magic happens, I suppose. And so I'm just going to run this. And that is actually going to take a while. So what I might do is show you one I did earlier. Maybe I'll just train for 5 epochs to start. Does anyone have any questions? Cool. So the idea.
So are you, sorry, are you training on the entire data set right now? So the 10,000 images?
I'm cheating a little bit. So I can show after. I can show you after what it would look like if we trained on the small sample. So okay. Even if we train on the small sample, even if it gives us like, even if it doesn't give us any decent outputs. So like when I ran it for just a few epochs, I basically just got noise as the output when I ran on the sample data. And so I'm like, it's possible that it might work if I run it for longer. But I'm basically not sure that you can overfit DCGAN on 2 samples. I know you can do it for other types of models. But even if we just get noise as outputs, that does tell us something. It tells us that the model runs on the data in the format that it's in. So like if we could get an error that says, you know, no such folder exists or something like that. And so even if we can't generate and even if we can't overfit on the small sample data for a particular model, it's still useful to do this because we know that the model runs on the dataset structure. And so we've defined the dataset class in the right way and that it all works. And so that means that even though we're not getting realistic outputs for small sample data, we can be confident that if we use this model on the full dataset, at least the model will run, I guess. Mm-hmm. Okay, so yeah, so I just ran that for 5 epochs there. You can see the generator and discriminator loss during training. So it goes a bit mad here, which I've seen a few times, and I don't know why. But so this is what it looks like after 5 epochs of training. Maybe this is the sample data. Why are they all the same? And also we've got this, like, PyTorch gives this kind of like the progression of training. So the first one is the first epoch, and then we get the 5th epoch. So what I'm going to do is I'm going to run this for longer, and then I'm going to show you the ones I ran earlier.
Okay, I don't know, maybe this is too simple here, but the thing is, I am trying to understand as you're going. So then, so there's some metric that is outputted by what part exactly? The loss function that you're showing, like, and it's, how do you plot that? That's the metric for training, is that right?
Yes, exactly. Yeah. So we call it like loss function and metrics, different thing, I guess, in machine learning. But okay. Yeah, so the loss function is binary. cross entropy. I'm not actually
Okay.
sure how you use that to train with DCGAN. I haven't dived into it too much. I don't know, Holly, are you familiar?
Oh, no. Mm-mm.
Yeah, I'm just kind of using it as like a black box at the moment, I suppose. But
Mhm.
if you're interested in diving into how it works, I can do that. We can do that offline, and I can
Sure, yeah.
analyze that.
And then the images that it was outputting, was it from the generator or the discriminator or what exactly?
So what the discriminator usually does is it tries to, so your generator is going to generate like
Fakes, right?
real
Or
images, and the discriminator tries to distinguish between real images and fake images. The idea is that if your model gets really good at fooling the discriminator, like if the discriminator is not able to tell which ones are real and which ones you've generated, then that's kind of being used as an additional loss function. And so we're using the binary cross entropy loss, but we're also using the discriminator as a kind of learnable loss. And so we have two loss functions really. The first one is this binary cross entropy, and the other one is whether we can fool this discriminator into like which image is real and which is fake. Does that make sense?
Okay. It makes sense between trying to like generate fake, but for our purposes here, what overfitting is an output of which part of the GAN then? Like overfitting is just taking it'll just be similar, but like some weird curves and stuff like that, right? And that's the idea, that's the art that's being generated, correct?
So yeah, the idea of the GAN is that it learns like a representation of the data set. And so if we had 10 image samples, we could learn a representation of that image data set, and then we can interpolate between different samples. And so like maybe one image has like glasses and one type of face, and another one has a hat and a different type of face. And so we'd be able to like, maybe combine different features from different images by looking through this latent space, as it's called. And so what I thought might happen with overfitting on a small sample of images was that the DCGAN would just reproduce so if we trained it on a single image, a data set of a single image, I thought DCGAN would just reproduce that single image. Where if we trained it on two images, I thought it might just interpolate between those two images, for example. But I've actually never done that before, and I'm not sure that actually happens.
And the output is like final images that are generated are the overfitted images, but they've been generated by the obviously the generator network, right? And then
these aren't overfitted because I'm training on the whole data set. So
right.
But what I can do is I can try to train that on the sample again and see if we can get anything meaningful. So I trained it for like 1,000 epochs or something, and it just looked like this. It just looked like noise, basically. But 1,000 epochs might not be that much because, if we do 25 epochs here, each of these epochs has 10,000 images. So whereas if we do an epoch on a single image, it's seeing much fewer images. And so I might need to train it for much more than 1,000 epochs. So what I can do is set that running and let you know how that went offline or something like that. And we can analyze a bit more. So this is after 25 epochs. So you can see that compared to last time. Maybe I can show you what it looked like last time. So this is after 25 epochs, and you can see that it's learning a bit more variation. And if we watch the progression, we can see how it starts to train, which is kind of cool.
Just is binary cross entropy like a standard loss function for GANs?
Yes, so like there's only really two loss functions you ever use in machine learning. The first one is like mean squared error or something like that, which is just basically, so in machine learning, you you have a prediction from the network, and you also have, you know what the answer is, right? You have the ground truth. And so we calculate the difference between the ground truth and our prediction. And then we can change all of the weights of our network in a particular direction to reduce the difference between those two, basically. And so if the ground truth and the prediction are numerical values, we use like a mean squared error. So we just take the difference between them and the squared difference between them, or like even the square root of the square of the differences, or something like that. So that's what we use for numerical values. And then binary cross entropy is usually used for like categorical values. So if we had two different categories like cat and dog, and we wanted our model to learn images of cats and images of dogs, like what we would do is we would codify cat as 0, say, and dog as 1. And so our prediction, the prediction of our network might be 0, whereas our ground truth says 1. And so we don't want to use like a numerical error value there, because like the difference between 0 and 1, it actually has no meaning in terms of the difference between cat and dog. And so that's why we use this different loss function, which is binary cross entropy, I guess.
Oh yeah, so it's basically like the binary cross entropy is there because it's a classification problem for the discriminator to say whether it is a CryptoPunk or it isn't.
Exactly.
Exactly.
Yeah.
Real or fake are the two values, the binary values, real or fake. Yep.
Exactly.
And that whatever's coming out of the discriminator will then, and then you can run this loss function on that value, on those values as they come out.
Exactly. Yeah. And so, yeah, that's it exactly. So it's a classification problem rather than a regression problem. And regression problem is the same as what I was talking about, the numerical values.
Yeah, keep in mind there are many different flavors of GANs out there. Like an early iteration. So basically with GANs, you're not really guaranteed convergence. Sometimes you get, they call it the unforgiving teacher, where basically the discriminator is too good for the generator to learn, and the generator doesn't really get anywhere. And so anyway, there's a bunch of iterations on this, on these algorithms that, you know, changing different normalization layers, changing even the loss function sometimes. One of the early iterations was the least squares GAN, where they actually do use like a MSE loss. But the most intuitive way to understand this is thinking of just classification between discriminator learning binary classification. Is this a generated or a real image from our data set? And then that signal is used to teach the generator as well. And they kind of co-teach each other, because the generator gets better at producing realistic images. And then the discriminator gets better discriminating between generated and realistic images. And hopefully at the end, the generated images are almost identical to the realistic ones. So, yeah.
Exactly.
But for our art purpose, what would be the overfitted kind of image? Like who would produce that? Or am I not making any sense?
You mean for like our use case?
Yeah, like what we're talking about, right? Like we're going to generative art, right? So
yeah.
Totally new kind of images, but in some
Yeah.
weirdly nice ways or funny ways, whatever. So
yeah, like I have a few different ideas for this. Like I guess, yeah, like the main goal is to generate NFTs that people are interested in buying, right? So with CryptoPunks, for example, like if we could come up with some ones that look like kind of like CryptoPunks, but maybe some like dreamy version of CryptoPunks or something like that. I guess that's like the first step. And then the second step is that once you train these GANs, there's ways that you can interpret the latent space. And these are, you can kind of push a GAN in a certain direction. And so I could figure out that some dimension in the latent space is related to the fact that a CryptoPunk has glasses or not. And that means that if I move in this direction in the latent space, I can add glasses to a CryptoPunk, or maybe a different dimension is like a hat or something like that. And so what I was thinking is that like, so how a lot of these NFT projects work at the moment, like even CryptoPunks itself, for example, they create like they basically overlay images on top of each other. And so they have like a base CryptoPunk, which is a certain type of face. And then maybe they have like a PNG of glasses, which they overlay on top of that. And then maybe a PNG image of like a hat. And so I think like they say that they create these NFTs generatively, because they basically just create some data set of like, we want, 50% men, 50% women. We want like 1% to have glasses, 5% to have hats. And then they write all this code to generate these, and then they just press go basically. And they layer all of the different attributes on top of each other. But what that means is that, like, I think it's quite hard to do, first of all. And it also means that the images often look quite similar. But what we can do potentially by using GANs is we can add these attributes such as glasses and hats and different types of things to more like to images that have more variation. And so like there's even examples of using GANs where you can like apply clothing from one image to like a human in another image and all this sort of stuff. And so you're not just like layering clothes on top of them, you're actually using the GAN to kind of learnably add clothes to images and things like that. And so if we could figure out the latent space of these GANs and like maybe the different dimensions that correspond to different things like glasses or hats, and just play around with those, I think it could be a really interesting use case for future GANs that don't just layer images on top of each other to create NFTs, but actually use GANs to generate things that look realistic. Does that make sense?
Yeah, and I shared a one that I've used before. It's called GAN Space, and it's basically kind of a visual way of determining the controls. It kind of shows different going across different parts of the latent space basically, and then you can say, okay, this one particular one adds glasses, between so and so layer. This is for StyleGAN too, though. So I don't know if there's a similar thing that we can use for DCGAN.
Okay, very cool. Yeah.
Does it use like an auxiliary classifier for these different things?
Yeah, so they when you
okay.
initially run it, yeah, I'm not too sure exactly how it works, but when you initially run it, it just comes up with this this list, and then you figure out on your own what it means, what each direction in the space means, and so then you can start labeling them. So
okay, yeah,
just an interactive way of kind of visualizing the movement through the GAN space, and then you can also minimize which layers are modified. So typically, the first couple layers are larger scale changes, and then as you get towards the later layers, and it's just color changes, those sorts of things. So it's pretty cool.
Very cool.
Yeah, so I've worked a fair bit with GANs. Two ways I think that we can also achieve this. If we have the attributes of different NFTs, so like cigarette, yes or no, different color hair, glasses, nice, yes, no. Then you can learn a conditional GAN and just have these attributes as sort of categorical variables. If you actually, another way you can explore the GAN space you can learn what's called a BiGAN. So basically your generator maps from latent noise variable to image, and then you just learn in tandem another network that goes from image to latent space. And that kind of will basically tell you, given this NFT, what's its representation in our GAN's latent space. And then we can kind of like interpolate between two NFTs if you want. It's kind of like another thing.
Very cool.
So,
do you have a certain conditional GAN model that you would suggest that we'd use if there was one?
Well, there's the first. I would start just with the really basic one where you add. I think they just call it CGAN or something. Conditional GAN.
Yeah, I found it. Okay.
Yeah, and then they also have different ways you can condition the discriminator, so it's a better teacher and and so on. Maybe we could start a GAN reading list if we're because there's so much literature out there. You can really build your whole career just on GANs, actually.
Yeah. That's a really good idea, actually, a reading list.
Yeah, there's also some good posts on the machine learning Reddit that just has like a compiled list of like 20 different tricks to help GAN convergence. Like using larger batch size, you can do like kind of latent space optimization, like all these different tricks and so on. So that would be good to know as well for these kind of projects.
Very cool.
Anyway,
Yeah,
I'm done.
very cool. Yeah, just to show you, like this was after 5 epochs, the ones that I ran earlier, and then this was after I think 25, and then this one was after 100. And so these ones look pretty cool. I'm not sure if these actually exist or not, but they look like they could be real NFTs. I don't know if they're like interpolations between. So that would be really interesting to figure out if these generated images actually exist or did it interpolate between. I'm not too sure.
It's pretty crisp, actually. This is
yeah, it's nice. Isn't it?
I'm surprised. Yeah.
So,
I would buy one for a couple $1 million.
Nice.
Couple $1 million.
We're gonna be rich. Yeah, cool. So like, I guess there's a few different aspects. There's a few different directions we can go with this project. Like the first one is like in GAN research, like just trying out different GANs and stuff, which is really interesting. And the aim there is just to like create interesting looking NFTs. And so, yeah, like that's great, but it's also something you can do without Ocean, right? We could just train GANs locally, create interesting looking NFTs and like sell them on OpenSea, for example. So I think we should like pursue that direction. But I think we should also pursue this idea of training these using compute to data as well. And the reason that that is interesting is because there's lots of artists collect their own data sets for training generative models like StyleGAN and well, DCGAN probably not so much, but and like that becomes a really like it becomes a really important, like they're quite protective of these data sets because they take so long to collect, and also like enables them to generate unique art. And so like we basically have like data silos of data sets by artists. But if we could guarantee those artists privacy in like collaborating with other artists, for example, using compute to data, you could get really interesting combinations of different data sets. And so one artist could agree with another artist to do a collaboration, and artist one could send their model to artist two's data set, and then the trained model will be returned to artist one. And so you could have these interesting collaborations between artists that might not be possible at the moment because artists think that if they want to collaborate, they actually have to, send the data set to them. Like, and then there's a risk of whoever they send the data set to will like send it to another person. They basically lost control of it. But if we can come up with a use case that uses the Ocean infrastructure, I think that's also a really interesting dimension to take this project. And so I think we should pursue both, and like we can start to put up issues in both of these directions as well, which would be really interesting, and people can work on whichever they're most interested in. And the other thing as well is that even like we're playing with generative models now, but there's use cases for generative models outside of art. And like one that we keep mentioning is that you can generate synthetic data using like StyleGAN, for example. And so the idea would be, imagine that there's this massive face data set on Ocean, and it has the potential to be the biggest in the world because people get to keep, like, people can make data sets of faces available without like putting them publicly online. And if this happens in future, we could train StyleGAN using compute to data or federated learning on like, a massive face data set. And then we could generate synthetic images using StyleGAN, faces that don't exist. And the advantage of generating faces that don't exist is that there's less like issues with sharing those publicly because, they're not humans or whatever. And so you could create this model that generates synthetic data to train, like, I don't know, facial recognition algorithms or like, whatever other thing on with faces. And so like that's one other use case. And then even today, I just came across, I think it's a paper for generating like cellular biology images. So I think they train like a generative model on a data set of cellular biology images, and then they use it to create synthetic data for training, I guess, better like cell classification models and things like that. And so there's loads of use cases for these generative models outside of art. And if we can figure out how to train these generative models in a private way using ocean infrastructure, then we can use it in applications that are more sensitive, like with people's faces or with like people's cellular biology and all this sort of stuff. So yeah, I think we should continue with both in both directions. What does everyone think?
Yeah. Would it be valuable if we, part of the project, we made a sort of GAN zoo?
Yeah,
Like a model zoo for GANs?
for sure. Absolutely. Yeah.
That could just be injected into these decentralized projects and so on.
Yeah, absolutely. And there's, I think, yeah, that would be like a really cool library of, like, this is potentially somewhere where Algovera could write a library that, you know, gives you, allows you to use all of these different generative models out of the box. It's kind of like what, I think Holly probably linked this to me, but it's like, it's called machine learning for artists. And they have like a GitHub library somewhere. And I think all they do, I was just looking at this earlier, they just, they have these sub modules for like all of the state-of-the-art generative models. So like this is Clip. That's another interesting one we haven't talked about. That's like, this one matches images and text. And so you can like write text and generate images when you combine it with DCGAN. So there's like all sorts of applications here. It has all the style GANs, neural style transfer. And so like a model zoo could be something as simple as this, or maybe we like standardize the format or something. But I think that would be really interesting if we just had an Algovera library where you could, you know, download a data set from Ocean really easily. And like we could make it so that all of the image data sets have similar formats, which means that they'll work with all of the models in this model zoo. And so maybe you could just even like choose data set from a drop-down menu, choose model from a drop-down menu almost, and just run and see, and just make it really easy for artists to like use these models. I think that would be really, really cool.
So the one you just showed that us, is that, are those pre-trained?
I think, yeah.
I would imagine, yeah.
I think each of these individual submodules like provides like a function to load a pre-trained. So yeah, I think I was looking through the notebooks and it's just basically like yeah, it loads a pre-trained model. So yeah, like if we can just like, this is the simplest way, obviously, just to use submodules. It also, yeah, but it would be cool to have like our own format for a model zoo as well. So I'm open to both for sure.
I'd also be interested in the, setting up a Docker file to train on AWS too. So
okay,
that to me is pretty important to me, is to, figure out how that would work with Ocean. So
fantastic. Yeah. Yeah. So like, that's what I'm going to work on this week is basically, yeah, we've just trained this. So if you're a data scientist and so what have you done so far? You've downloaded the data set from the Ocean Marketplace and now you've trained the model on like, I guess the sample data, but we kind of cheated because it was the full data set. But once we're happy with this model, like what we could do is we could write some function that exports this Jupyter notebook into a Python file, just a text file. And then, so we just write export this notebook, and then we have to publish the algorithm so that it uses this. So I guess once we export this model, we would probably need to put it in like a GitHub repository. And then we need to create a Docker file that will run on it. So far I've used compute to data so I just ran the example that Ocean gives, and they use like a standard Docker file. But if like this one is going to have to be a custom Docker file because it has like PyTorch, for example. And so what I'm going to be working on is trying to get Ocean compute to data working on custom Docker files. That's one thing. And then also publish an algorithm, basically just create a repo or a file for this model, and then publish that on the Ocean Marketplace, and just basically do the same thing that we did here, but just using compute to data. So just like setting up the folder structure and all that sort of stuff. So yeah, I'll be kind of working interactively on that in the issues. So I'll put up a few more issues and stuff. And if people have time, like chip in, or like hopefully by next week I'll have figured it out. And we can run through and actually do this exact same thing, but using private AI infrastructure. I think that would be really cool. And
That sounds like a lot of work for me, for you actually. So it's a bunch of work, but yeah, it'll be great to see it.
actually, I'm just thinking there was another step before, which was like do a really simple algorithm, which was like count the number of images in the data set. Because to train this like this, we need to set up our own compute provider. And so it might not be next week, it might be like the week after or something like that. So maybe for next week, we'll run compute to data with a really simple algorithm, which just basically counts the number of images in the CryptoPunks dataset or something like that. And then the following week, we'll finally run training. I think when we've run training, that's basically like our last step. I think that's like almost the whole process of, you know, creating an algorithm, publishing it on the marketplace and all that sort of stuff. Cool. I think we're just over time at the moment. Don't know, does anyone have any questions before we start to finish up? I didn't get a chance to go through the compute to data notebook, but I guess we can do that offline and go through it next week a bit as well.
Yeah, sure.
Okay, great. All right, maybe we'll leave it there.
All right, sounds good.
Thanks, Richard.
Thanks, Eric.
I'll risk turning
Thank
on
you.
my camera and see if my computer breaks. But yeah, cool. All right. Getting through
Thanks.
it.
See you all next week then.
Cool. And yeah, I'll keep in touch with you on like GitHub issues and Discord channel and all that sort of stuff. And let me know if anyone has any questions or wants some job to work on or something like that.
All right.
Okay,
Thanks.
Yeah.
great.
Keep an eye out.
All right. Thanks, everyone.
Thank you.